Hey guys, it's Mrs. Notzel. I hope you guys are doing well and that the e-learning is coming along well and you guys are getting all your work done. Um, I know that this week in math we're working on volume, and so I made this cool little like tool to kind of help you. I It's a little like anchor chart, I guess you could say. I drew the cube. I didn't draw the individual little boxes, but to find volume of a cube. Now remember, a cube is like the flat shape is a square, so the 2D shape is a square, and a square all sides are the same. But in this cube, to find the volume, all you have to do is take the length times the width times the height. Okay, and sometimes they're written all together. V for volume equals L times W times H. So remember, when they're written right next to each other, that means multiplication. And then I did the colors up here on the cube to match the shapes. Okay, so this is just a little visual to help you with volume. But today's lesson, or yesterday's lesson that you did, Tuesday's lesson that you did, we started off with fractional dimensions. And so it's more about multiplying fractions. So this rectangular prism is not, it's a rectangle, so not all the sides are the same. And the problem says a child's sandbox is 5 feet wide, 4 feet long, and 3 feet deep. Grace fills the sandbox so that the sand is 2.5 feet deep. What is the volume of the sand in the box? So remember, when we used to solve for area, we were solving for the outside of the shape. Now we're solving for the inside of the figure. So when we're talking what this problem is about, we're talking about a sandbox, and we want to find out the volume of the sand in the box. So the first picture they show you, they made a sketch and they showed you that the sand is 2.5 feet deep. So the height is 2.5 feet right here. It's 4 feet long and 5 feet wide. Okay, so we know that the volume for formula is to multiply the length times the width times the height. Okay, so we're exploring different ways to find the volume of a rectangular prism whose dimensions are not all whole numbers. So we're going to have fractions. Then I want you to look at this model where it has the individual like cubes for you so you can see. Now remember from our lesson last week, the top and the bottom are the same. So this first question, number 2, it says look at the modelet. So we're looking right here at this modelet. Says how many cubes are in the bottom layer? Explain your reasoning. So if you look, the bottom layer is the same as the top layer, but you know that it's 1, 2, 3, 4, 5 across and 1, 2, 3, 4 deep. So 5 times 4 is 20, but you could also count the boxes up here and see that it's 20. So it's 5 or 4 rows of 5 items or 5 cubes. So here it would be 20, and explain your reasoning. You have 5 across and 4 deep. So 5 times 4 is 20. How many cubes are in the next layer? There's 20 cubes because you have one layer right here and then you have a second layer right here. And so it's the same. It's 5 rows or 4 rows of 5. Okay, then number 3 says, how many whole cubes can you make with the blocks in the third layer? Okay, so when you're looking at this, this is only half of a cube, right? So you would need 2 of them to make one whole. So this is a half and this is a half. So that's 1, then 2, then 3. But if you think of it, you know that the bottom two layers had 20. So if the top layer has 20 half cubes, then how many whole cubes would that be? Well, it would be 10, because 10 times 2 is 20. So this answer that you got for number 3 should have been 10 whole cubes, because there's 20 half cubes. All right, then it says, explain how to use your answers in problems 2 and 3 to find the total volume of sand. Okay, well, you know that there were 20 cubes in the bottom layer, 20 cubes in the next layer, and then 10 whole cubes in the top layer. So if you added those all together, you would get you would get 20 plus 20, which is 40, plus another 10 is 50. Then you use the formula volume equals length times width times height to find the total volume of the sand. Now, when you're doing that, hold on, let me grab a dry erase board. Okay, boys and girls, I'm sorry, I needed to get a dry erase board. Okay, so now they're wanting us to use this formula, volume equals length times width times height. So in our problem, when we look up at the top, we have 5 times 4 times 2.5. Okay, so we already know that 5 times 4 is 20. So we would write that on our dry erase board. Volume equals 20 times 2.5. Now, in order to multiply that 2.5, we have to change that mixed number into an improper fraction. Now remember, an improper fraction means that the numerator is bigger than the denominator. So the really simple formula for doing that is take the denominator, multiply it by the whole number, so 2 times 2, which is 4, and then add it to the numerator. So 2 times 2 is 4, plus 1 more is 5. So you're going to be multiplying 20 over 1 times 5 over 2. Like that. Then we know 20 times 5 is 100. So then we'd have 100 over 2. 100 over 2, 100 divided by 2 is 50. So our volume is 50, and the measurement was feet. So it would be cubic feet. So you can write it 2 different ways. You can either write it as 50 with the 3, or you can write 50 cubic feet. Okay. Now the just like with area, we always had to put a 2 up there because it was squared. For volume, everything is cubed because we're multiplying it by 3 numbers. Okay, so everything is cubed. So you got the same answer when you multiplied in number 5 as you did when you took each layer and then you added them together. Okay, number 6 says, describe how to find the volume of a rectangular prism when the dimensions include fractions. So when you multiply fractions, you multiply straight across, okay? And so there's really no difference when you're finding the volume of a rectangular prism when the dimensions include fractions. It's just that you have to end up solving with those fractions in it. So you multiply straight across, and if there's still a numerator and a denominator, then you can divide them, or you leave it as a fractional part. Okay, so that now we're on to 7 and 8, which was your exit ticket for today. So it says the length of a box of colored pencils is 6 inches, the width is 4 inches, and the height is 3/8 of an inch. What is the volume of the box? So again, you just solve it out. You take 6 times 4 times 3/8. Okay, 6 times 4 is 24. And then you're going to put 24 over 1 times 3 over 8. Okay, 24 times 3 is 72 over 8. When you divide 72 by 8, you're going to get 9 cubic inches. Okay, and there it is solved out for you in case you need to see it. All right, number 8. The width of a recycling bin is 3/4 foot. The length is 1 foot and the height is 1.5 feet. So again, you have 3/4 times 1 times 1.5. Now we know when we multiply anything times 1, it is that number. But the 1.5 is a mixed number. So in order to multiply that, you have to change the mixed number into an improper fraction. So you take the denominator, you multiply it by the whole number, and add the numerator. Okay? So 2 times 1 is 2, plus 1 more is 3 over 2, times 3/4, and times 1, we know that we're still going to get the same answer. So 3 times 3 is 9, 4 times 2 is 8. So you can get 9/8 cubic feet. If you wanted to change 9/8, you could change it to 1 1/8 as your mixed number, and that's still the same answer. Cubic feet. Okay? 9/8 or 1 1/8. We would have accepted both answers. All right, and I think I'm going to put this little anchor chart that I made, and then I'm also going to put the how to change a mixed number into an improper fraction on Google Classroom as well. Okay. I'm going to go ahead and stop this video, and then I'm going to go over pages 290 to 291 so that the video is not too long.